Okay, task 2. Consider the geometric sequence 125, 50, 20. First thing I'm going to do is write this as a table. First term is 125. Second term is 50. Third term is 20. We want to write an explicit rule for the sequence. They tell us it's geometric. So to write that explicit rule, since it's geometric, I know it's going to be a times b to the x. Okay, so I need to find this common ratio. So I need to do some dividing. Oh, nope. Sorry. Just wanted to bring up a little calculator. So I need to take 50 divided by 125. We get 0.4. 20 divided by 50, 0.4. So it looks like that common ratio is 0.4, which is 4/10, which is 2/5. So my common ratio is 2/5. So there's my common ratio. Okay, so that's my b, 2/5. So I have 2/5 to the x. Now I need to find my a. To find my a, I go back one term. So to go back, we're going to go bigger. So instead of, I need to take 125 divided by what? Is 2.5. So I would need to take the 125 and divide it by the 0.4. Oh, sorry, guys. I don't know why that's not working. Click. Okay. So 125 divided by the 0.4. And I get 312.5. So let's double check it. Divided by 312.5. There's my 0.4. So I know my 0th term is 312.5. So there is my sequence. So we want to write it in function notation. F of n equals 312.5. Since we're going decimal, we can go ahead and do decimal, 0.4 to the n. So there's one way of writing it. The other way, f of n equals, we use the first term, which is 125, times still that 0.4, but now it's to the n minus 1 is the exponent. I'm going to write it this way. I'm good with either one. You choose which method you will remember. Okay, what is the domain of the function? Domain, I'm looking at the inputs. Since this is a sequence, my domain would only be the whole numbers. So my domain would be starting with first term, second term, third term, dot, dot, dot. Keeps going that way. No in-betweens. So when graphing this, we do not connect the dots. Okay, because we would never have a term in here that's 1.5, okay, or 2 1/3. Okay, it doesn't have any of those in-betweens. So that leads us here to graphing a geometric sequence. So here we want to graph this sequence. F of n equals 20 times 1.5 to the n minus 1. Notice this is written the textbook way, n minus 1. And we want to do it for n's in between 1 and 5. So I'm going to do that by setting up a table. 1, 2, 3, 4, 5. So I want to put in the numbers 1, 2, 3, 4, and 5. So I can grab my calculator and take 20 times 1.5 to the 1 minus 1, which gives me 20, which makes sense because that's my first term. Okay, now we go ahead and do the second term. 20 times 1.5 to the 2 minus 1 gets me 30 because my common ratio there is 1.5. So 20. Basically, I'm multiplying by 1.5 each time. 1.5 to the 3 minus 1 is 45. Okay. And so I could get it by just multiplying by 1.5 each time. So I could take 45 times 1.5 is 67.5. So 7 times 1.5 is, 67.5 times 1.5, 101.25. All right, so now we want to graph it. My inputs over here, there's my domain, are only the numbers 1 through 5, so only the positives. So I only need to deal with the positives over here. Okay, and my outputs, my range over here, my range is numbers from 20 to 101. So maybe count by tens. So here, let's spread this out a little bit. I'm going to go over by 3. There's 1, 2, 3, 4, 5. And then here, maybe count by tens every 2, 10, 20, 30, 40, 50, 60, 70, 80, 90. There's 100. So you need to go 100. So the first term is 20, puts me there. The second term is 30, puts me here. The third term is 45. 10, 20, 30, 45 would be there. The fourth term, 67.5. So here's 45, 50, 67.5 would be right about here. And the fifth term is up here at 101. So right about there. Okay, again, so we can see it does have kind of that curviness of an exponential, but we don't connect the dots. It's just those points. Don't connect the dots, because we're not talking about the in-betweens. By connecting the dots, you are including all the numbers in between 1 and 2, which we don't input any numbers in between 1 and 2 because it's just a sequence. So what is the domain and range? Well, we kind of nailed it. The domain, we stated up here, is the numbers 1, 2, 3, 4, 5. There's my domain, the numbers we put in. The range, there's the range right there. 20, 30, 45, 67.5, and 101.25. There is the range because we're only putting in the numbers 1 through 5.